Today I am going to discuss group 13 element. Mainly I will focus on boron. Group 13, there you will get boron, aluminium, gallium, indium, thallium. And the electronic configuration there, NS2, NP1, general electronic configuration, that is 2s2, 2p1. This is 3s2, 3p1. 4s2, 4p1, this is 5s2, 5p1, and this is 6s2, 6p1. And they are normal valency, boron normal valency 3, here also you will get 3, here also you will get 3. But indium you will get 2 valency or 2 oxidation state, one is +1, another one is +3. This +1 oxidation state due to inert pair effect, down the group S electron becomes inert highly. Due to penetration effect of S is very high. And thallium, remember, thallium +1 stable oxidation state, stable. +3 unstable. All chlorides are trihalides, BCl3, AlCl3, JCl3. For indium, you will get 2 different chloride, InCl and InCl3. These 2 different oxidation state due to inert pair effect. But highly inert for thallium, 6s2 highly inert, and its stable oxidation state +1 and +3. And the formula of thallium chloride TlCl. At normal temperature, actually TlCl3 will undergo com proportion reaction. It will reduces to TlCl +3 to +1. And chloride -1 oxidizes to chlorine. At normal temperature, this will happen. That's why at normal condition, thallium chloride, the formula is TlCl, not TlCl3 due to inert pair effect. Now I will focus mainly on boron and boron compounds. Actually, boron is an important element in the periodic table after carbon. Carbon containing compounds, huge number of carbonic containing compounds. They are called organic compounds, more than 2 lakhs. Boron hydrogen compounds are simply called boron hydride. And after hydrocarbon, huge number of boron hydrides you will get here. They are called boron cage compound. Boron cage compound, since they are structure like cage. Boron cage compound. And we have simplest boron that are called boron also. Simplest boron is B2H6, that is the dimeric form of BH3. And this dimer form, since in BH3 their effective number of electrons are 6, and by formation of BHB bridge bond they will form dimer, and that BHB bridge bond is called 3 center 2 electron bond. 3 center 2 electron bridge bond. This is bridge bond or called banana bond. Here the 3 center, 2 boron and 1 hydrogen. This is also 3 center 2 electron bond, 3C2E bond, and this will form due to electron deficient characteristics of boron. And boron trihalides are double. Since boron has vacant p orbital, there it has a tendency to accept electron pair. Here BHB bridge bond, 1s orbital of hydrogens make overlap with 2p of boron. 2 boron atoms, 2p, and simultaneous overlap will occur, and molecular orbital theory will give clear idea. There 3 MO will get, and ground state MO occupied by 2 electrons, and that 2 electrons are symmetrically distributed among the 2 boron. This is called 2 electron 3 center bridge bond. Now, this is simplest boron. Any boron, you can easily calculate number of bridge bond present in the boron. For example, if the formula of boron B4H9, this is also a boron cage compound, boron. And how do you will calculate number of bridge bond? Actually, for neutral boron, this is neutral boron, no charge you will get on this compound. For neutral boron, number of bridge bond always equals to the number of boron atoms present in the boron. And the simplest formula you can use to calculate the number of bridge bond present in a particular boron, that is the number of available orbitals. Number of available orbitals, that means the valence orbitals which are able to form the bond with other. And you know each boron has 4 number of available orbitals, 2s, 2px, 2py and 2pz. And 4 number of boron has 4 into 4 number of available orbitals. And each hydrogen has 1 s orbital that can form bond, 9 into 1. That means these are the available orbitals that can form bond. That are the valence orbitals. Now I will count the number of available electrons that can participate to form the bond. And you know each boron has 3 electrons. Each boron has 3 electrons that can form bond, and each hydrogen has 1 electron. 9 into 1. Just the difference of these two is the number of bridge bond present in a boron. And difference you will get 16 plus 9, 25 minus 21. That is 4 number of bridge bond present. And you know boron, remember, you will get 2 types of BH bond. One BH bond, that is exo bond, not participate to form the cage structure. Another BHB bridge bond. Here also BB normal bond you will get 2 center 2 electron, and BBB bridge bond also you will get here. The 4 number of bridge bond you will get in before H9. By using this concept you can do calculate easily number of bridge bond present in a particular boron. For neutral boron I told you number of boron atoms equals to the number of bridge bond present, but for anionic boron you will get, there you have to do count. By this way you will get the number of bridge bond. Now remember, this cage-like structure of boron are of 3 types. One is called Closo structure. Closo structure. Another you will get Nido structure. Nido. And the last one is Arachno structure of boron. And remember Closo stability order, if I do right, stability order, Closo greater than Nido, greater than Arachno. Remember. Now, in the question, formula of boron given, how do you will get which one Closo, Nido or Arachno? That I am going to discuss which structures belong to Closo, which structures belong to Nido and Arachno. Closo general, you will get ionic boron BnHn2 minus. These are always Closo structure. Closo means, for example, tetrahedral Closo. That means all 4 vertex of the tetrahedron are occupied by boron. Trigonal bipyramidal Closo, 5 vertex are occupied by boron. Octahedral Closo, 6 vertex are occupied by boron. Icosahedron, there you will get 12 vertex are occupied by boron. That are Closo structure, most stable structure. And remember the general formula BnHn2 minus. And here the number of electron you can do count 3n, 1n, 4n plus 2 electron if involved, then it is Closo structure. And isoelectronic BnHn plus 2. 2 minus I have replaced by 2 additional hydrogen. Here the number of electrons are same. Both are Closo structure, remember. And this is very common Closo structure. This is rare, remember. Neutral boron, rare Closo structure. Carbon 2B minus, you know B minus equivalent to carbon. 2B minus you can replace by 2C. That means Bn minus 2 C2 Hn. This is also neutral carbon and belongs to Closo structure. Now the Nido structure general formula BnHn plus 4. Here the number of electron 4n plus 4. If the general formula BnHn plus 4, then it is Nido structure. Nido means just withdraw 1 vertex from Closo, you will get Nido-like cage, and it's a stability less than Closo. And Arachno least stable boron structure, and its general formula BnHn plus 6, and do count 4n plus 6 electron involved in the boron cage compound. Just 2 vertex withdraw from Closo structure, you will get an Arachno structure, which is least stable structure of boron. Now, the most important part with respect to your syllabus, that is the cleavage of boron. Simplest boron B2H6 that we have. I will do cleavage of boron. There you will get two different types of cleavage of boron. One is homolytical cleavage, another one is heterolytical cleavage. So which one homolytical and heterolytical, that I am going to discuss. That is BH. This is simplest boron B2H6. Here also two number of bridge bond present, number of boron 2, and this BH are called exo bond, not participate to form the cage. Now, if the cleavage like this, that means BH3 both side, then both side becomes 2 moles of BH3, and this is called homolytical cleavage. Homolytical cleavage. Now, if the boron will cleave or break by this way, that means one side you will get BH4 minus and another side you will get BH2 plus. This is called heterolytical cleavage. Heterolytical cleavage. Heterolytical cleavage. Now you have to know, automatically the boron will not break or cleave. You know boron BH3, its dimer B2H6, these are Lewis acid. There you have to do attack by a base, then it will break. So some base will cleave or break the simplest boron B2H6 by homolytically, and some base will cleave or break by heterolytically. Now by taking mechanism of the cleavage, I will discuss which type of base will break the boron by homolytical way and which type of base will break or cleave by heterolytical way. See the mechanism. Now I am writing the simplest boron. I will do the mechanism. See H, this is H. Take simplest base ammonia and do attack by ammonia. What you will get? Ammonia, nitrogen has lone pair of electron. This is Lewis base, and you know this is a Lewis acid. If it will attack here, then it will break first. And what you will get? It is H2N. This is plus H. Single bond BH2. H, one bridge bond will remain, one bridge bond will break, and this is BH3. And you know boron acceptor, there you will get minus charge, but remember this minus is distributed among the two boron more or less equally, not exactly. I am writing here equally, minus half, let it is minus half, but exactly not equal. Now, you know it is ammonia is a weak base. To get neutralized, H plus will leave from here. H plus leave from here, and you will get H2N single bond BH2H single bond BH3. Here you will get minus, exactly not equal distribution but minus. Now this nitrogen again become a base, you will get lone pair of nitrogen. Now further it will attack, that means 2 times consecutive attack on same boron. First time here, second time here. Then it will break. See what you will get? H2N double bond BH2. This is plus, this is minus. BH2 plus side, and this part is BH4 minus. Actually, this is heterolytical cleavage. See. Now, what is the mechanism of heterolytical cleavage? What is the structural criteria of the base of heterolytical cleavage? See. 2 times consecutive attack on same boron by same basic center of nitrogen. First time here, and second time after leave of H plus, it becomes again base, again it will attack here. If it is possible, then there you will get heterolytical cleavage. Now the question is, when it is possible? See, after attack nitrogen becomes plus. That means the condition after attack it should get neutralized, then it will become again base. and it will become again base and it will neutralize if there are hydrogen. That means if there are hydrogen with nitrogen, then there will get heterolytical cleavage. Tell me, why do you get hydrogen? Ammonia, there are 3 hydrogen. 3 hydrogen is not required, 1 hydrogen is enough for heterolytical cleavage. If I take primary amine, there also you will get heterolytical cleavage since there are 2 number of hydrogen with nitrogen. If I take secondary, then also heterolytical cleavage since there are 1 hydrogen. But if it is tertiary, then no hydrogen with nitrogen, no heterolytical cleavage you will get. That I will show you. Now the next part, extended part, remember H plus you can remove from here and H minus from here. Hydrogen can leave from here and you will get H N double bond B H. Now you know it has vacant 2p. And here you will get lone pair of electron, you will get a coordinate bond, and you can do right. It is a H N triple bond B H. This is plus, this is minus. See, this N plus equivalent to carbon, B minus equivalent to carbon, and its structure like acetylene. It's like isoelectronic with acetylene. And you know when acetylene you will pass through red hot copper tube, it will form a trimeric ring, that is benzene. Here also you will get, but no red hot copper tube required, just give heat. The 3 moles of this equivalent to acetylene will polymerize to give inorganic benzene. See the structure of inorganic benzene. Alternate boron nitrogen, 3 moles of this BnH2 will polymerize. BnH2 will polymerize. This is boron, this is alternate boron nitrogen I have written here, and with each boron nitrogen there will get hydrogen. I have drawn here hydrogen also. This is called inorganic benzene or boragine. Now nitrogen donor plus boron acceptor, nitrogen donor plus boron acceptor, nitrogen donor plus boron acceptor. This is B3 N3 H6. That means if you give heat, boron B2H6 with ammonia, finally you will get inorganic benzene, which is too much similar to benzene, isoelectronic with benzene. Even Bn bond length very close to Cc bond length in the benzene ring, but it is too much less aromatic than benzene. Remember, its boiling point also less than benzene. But the question is the important point here. Ammonia, first it will cleave or break the boron by heterolytical way, and finally you will get acetylene like electronic isoelectronic molecule BnH2 that will form trimer inorganic benzene. Now I will show you homolytical cleavage. How homolytical cleavage will occur? I told you if I take tertiary amine, there are no hydrogen with nitrogen, there you will get homolytical cleavage. Take tertiary amine, R3N tertiary amine. First it will attack here. Similar mechanism like before, and what you will get? R3N plus and BH2 H BH3 near about equal distribution of charge minus. But you know this nitrogen can never be neutralized since there are no hydrogen. Now the second attack by tertiary, this will attack here and this will leave here. And what you will get? 2 moles of R3N donor plus and BH3 acceptor minus. This is homolytical cleavage. Now I can give example, multiple example which will break the boron by homolytical way, which will break the boron by heterolytical way. I am going to give example. Just remember the mechanism and I will correlate with the mechanism. I will give example, multiple example. This example I have given, since you know there are hydrogen, minimum 1 hydrogen required with nitrogen for homolytical cleavage, and this will do homolytical cleavage, homolytical. Again you can give example any ROH, here also alcohol, and there are hydrogen with oxygen, that's why there you will get homolytical cleavage. Now heterolytical cleavage, heterolytical, here consecutive attack, 2 times consecutive attack on same boron, there you will get heterolytical cleavage. This will give heterolytical cleavage. Heterolytical, that I have shown you the mechanism. Heterolytical cleavage, the condition is minimum 1 hydrogen associated with nitrogen. Now homolytical cleavage, 1 time attack by the 1 basic center on 1 boron. Homolytical cleavage. First tertiary amine, since you know the question of neutralization after first attack. If I take PH3P, triphenyl phosphine, you know on phosphorus you will get lone pair of electron, this is a base, and there you will get homolytical cleavage since no hydrogen with phosphorus. If I take tetrahydrofuran, no hydrogen with oxygen, homolytical cleavage you will get. PF3, homolytical cleavage, no hydrogen with phosphorus. Carbon monoxide you know is a base. Carbon has lone pair of electron, oxygen plus and carbon minus, and this lone pair is basic and no question of neutralization after fast attack. That's why here also you will get homolytical cleavage. Or less maximum example I have given which will do the homolytical cleavage, and this will do the heterolytical cleavage. Now I will discuss another topics in this part that is associated with boron. You know boric acid. Boric acid, H3BO3, boric acid. An important part. You know, apparently there are 3 hydrogen, but it is a weak monobasic Lewis acid. See the term. It is a weak monobasic Lewis acid. How it is weak monobasic Lewis acid, that I am going to show the mechanism. See, you know the structure of boric acid H3BO3, this is the structure, trivalent, and it has vacant to pure vital. These hydrogens are not acidic hydrogen, it is not Bronsted acid, remember it is a Lewis acid. Now put in water. Oxygen has lone pair of electron in water, it is donor, that is Lewis base, and this is Lewis acid. See, with respect to water it will act as acid. Now give reversible sign, what you will get? B tetrahedral, and you know tetravalent boron highly unstable due to steric hindrance. Since you know boron is too much small in size, valency 4 is unstable here. And water donor, you will get plus on oxygen, boron acceptor, you will get minus. Finally, H plus will leave from here, and what you will get? You will get BOH whole 4, tetrahydroxoborate. This is the conjugate base of boric acid, remember. So you got, it is a monobasic acid. Why it is weak? I told you, valency 4 of boron is highly unstable due to steric hindrance. Since these bonds are vibrating, there you will get collision between the groups, and these are unstable. Immediate backs to the reactant boric acid and water. OH minus will leave from here due to steric hindrance, that OH minus and H plus form water immediately. That's why it is a weak, since its conjugate base BOH whole 4 minus unstable due to steric hindrance. It is monobasic acid, it will give 1 proton due to attack of 1 water molecule, and it is a Lewis acid since the first step, the mechanism is Lewis acid and Lewis base. Now another part, remember, if you add here, if you add a syn-vicinal diol like ethylene glycol, then it becomes a strong monobasic acid. That means it was weak, it it becomes strong. Since that syn vicinal diol like ethylene glycol will form a spiro complex with boron. Spiro complex structure like this complex formed by syn vicinal diol like ethylene glycol, this type of complex you will get, boron minus. And it is highly stable. Since you know spiro, here the boron is the common carbon of the 2,5 membered ring, and these bonds are highly rigid in spiro. Due to rigidity of the bond, although it is tetravalent, steric hindrance minimizes due to rigidity of the bond. That's why it becomes highly stable. Per spiro complex formed by this tetrahydroxoborane, which is highly stable. Due to its high stability, due to conjugate base stability with syn vicinal diol, it becomes a strong monobasic